Okay. Well, before we get started, yeah, I want to ask how you guys are doing. It's okay. Homework 2. How did that go? How do you guys feel about your tic-tac-toe assignment? Any questions, feedback? Okay. Well, we have a midterm on Thursday, and I talked a little bit about it last week on Thursday. And yes, it'll cover just the first 4 lectures, first 2 weeks of class. So today's stuff is not going to be on the midterm. Okay. Any questions there? Yes.
Is it multiple choice or?
No, it's free response. No, not multiple. So the form is going to be, I'm going to have code. Okay. Not. Yeah, I'm going to have code, and I'm going to ask, what will this code output? Okay. Yes. Question. Yeah. Yes.
Will the lecture be similar to the practice lecture?
Maybe a little bit longer. Okay. The practice. So I gave it to your TA, but then I'll post it online as well, and you guys can take a look. And it's just a midterm that I used from a previous class, and I'll change it up, and things will be different, of course. But yeah, I mean, the format will be, here's some code. What will our output? And that one was written for a 45-minute class, so this one will be a little bit longer. Yeah, that will be that. Okay. So in today's lecture, we're covering regular expressions, and I think regular expressions are so cool, but they will not be covered on the exam. And I actually decided, and I was debating to do this or not, but I decided to remove the regular expression part out of the homework this week. Okay, so your homework this week will cover RVest, which we're going to cover today, web scraping, and then dplyr. And so you can get started on the dplyr stuff, which we covered last week. But yeah, okay. Any other questions? Yes.
How long will the exam?
I mean, we'll have the whole class session. So what's that? An hour and 50 minutes or something. So we'll have that much time. How long it takes each individual student will be different. Okay, and I think I'll set up a seating chart. Okay, and I know that's not fun, but there were incidents in the past, and I think some of those incidents could have been avoided with the seating chart. And so I will email out a seating chart probably tomorrow night, and you'll just sit in your designated seat and take the exam. Let me see. Are those left-handed desks on the end? Okay. All right. I'll send out an email, but reply to my email if you need a left-handed desk, and I'll try to assign you to a left-handed seat. Okay? And I'll do a quick survey of the classroom. Okay. Any other questions? Okay. Free response, midterm exam. I mean, short answer. What does the code output? Okay, then today we will cover this topic: importing data, scraping data, and text processing. There's a few chunks of things going on here, and there's some good stuff here, and then And then after this, next week, the course will start to feel different because we're going to start covering some basic computational statistics algorithms and things like that, and we're going to cover a few topics there. So this, we're still kind of focusing on programming with R and handling R, and then next week we get a little bit of a thematic shift after the midterm. So okay, so we have input from a file. We got basic commands like scan and read line, and I think you guys probably used read line to get input in from the user in tic-tac-toe, but you can also kind of assign a file, a text file, and it will read the lines in from the text file. And so these are kind of the base things, and we have read.csv and read.table, and these are kind of the basic commands that R uses to read data in from a file. So read.csv is basically like a customized version of scan or read line that says, when you read in the lines, when you find a comma, those separate out the text that you've read in based on the commas and stuff like that. And so if you took stats 20, I'm assuming you guys used read.csv. Is that what you guys used, or did you use something else? Read.csv. Okay. Did it ever do anything annoying? Read.csv? It always worked the way you wanted it to? Maybe? Okay. Well, one of the things that it could do, read.csv, that's annoying is character information, string information will import as factors by default, right? And so if you want it to remain as string or characters, you have to do strings as factors equals false. Anyway, so Hadley Wickham, being the prolific programmer that he is, said, I'm tired of this. I'm going to write my own read packages. Okay, so he created library read R, and you will use read_CSV, and that turns off. So it basically is the strings as factors is false. It also has performance improvements, so it works better for handling larger CSV files. It kind of tries to auto-detect the type of information. So it handles missing values better and things like that, right? So that's what we have, read R. If you've got Excel files, you've got read Excel, and then if you have data from other programs, like SAS, SPSS, or Stata, which used to be like super popular, and now kind of R seems to be taking over these different groups, right? So these are all kind of commercial products. SPSS, Stata, SAS. They're all commercial products, and R being free is kind of entering those spaces. But anyway, Haven will import those. Okay. There's also library data.table, which has a function called fread, which is like, I don't know what the F stands for, but it is fast. I don't think the F stands for fast, but it is fast. And so if you're in if you got a file that's like multiple gigabytes big, well, first of all, that might crash your computer, depending, because it's got to all fit in memory. But if you've got something, that's like 600 megabytes or a gigabyte or something, I would recommend data.table fread over any of the other functions, even over read_CSV. So fread for that. Okay, and then there's more stuff in this webinar that should get you there. Okay. There's also package downloader. Okay. There is R has a download.file function. Okay, and this will go to the internet, find a file, download it, and allow you to load it. Okay. And you might be like, why would I even bother with this? It's not hard to open a web browser, go to the website, click download, and things like that, okay? You're right. It's much easier to open the web browser and click download, okay? It's much easier to just say, go to this website and download this file. That's true. However, if you want to create a script and automate these things, you can't tell the computer, go to the website and download this file. You can tell a human that, but telling the computer, you can't just, I mean, well, I don't know. Now you can say like, hey, Siri, go to this website. But I don't know if it'll understand like download this file. Siri's kind of stupid as far as the things go. Google and Alexa, I think, are way better, right? Cortana, and who uses her, but and why are they all women? I don't know. But anyway, so we got install the packages downloader, and you can now put your download commands in a script, and it will be automated, right? So you do download. So download.file was great. Everybody loved download.file. And then, you know, on the internet there were all these bad people, and then everybody said, okay, we got to switch over to HTTPS. We got to make secure connections for everything. And download.file couldn't handle secure connections because it didn't understand what it needed to do. So library downloader lets you download over HTTPS, and so anyway, we got that now, okay? All right. So I guess I'm just telling you packages that are useful, right? I think that's one of the great things about R is that people have coded really good packages and functions out there. So if there's something you need to do, probably somebody else has done something similar that you can then adapt for your work. Another package, Lubridate, which is, I guess, a play on lubricate, but it makes things smoother for dates, right? And so let me just go over here. When you had date information, usually date information is always stored as like a string, okay? Because, so date information is stored as a string. And if you think about our calendar, it's really weird, right? Like, why are there 31 days in certain months and 28 in February, and like, it's weird, right? It's weird. And so in the computer, dates are almost always stored as like the number of days since January 1st, 1970 or something like that. I don't remember. There's like Unix day 0. And so, you know, if you say like, what is today? It's going to say like, it's this many thousand days since January 1, 1970 and stuff like that. And that's how computers store information. But you can't tell people like the date that way because they won't know what you're talking about. And somehow, you know, all of us have agreed on this Gregorian calendar. And now we need to be able to get dates from this form into something the computer understands, okay? And so it used to be you could do this function called as.date, and you had to specify using these %d, %b, and %y, and whether it was lowercase d or capital D, lowercase b, or capital B was very critical. So here we have 6th August AUG 2005, and we had to write %capital B, %capital Y to indicate that we have the year in 4 characters, and the for August it's, you know, kind of its abbreviated form of, or it's using, I don't know, a language, a word thing here, and it had to be perfect, okay? If, in this case, we have %B for January, and then a space, and if you didn't include that space there or put the comma here, like the date import would fail, and it would be very frustrating if you're dealing with date information. So here I'm bringing in my string dates. So this is the date written as a string, and you would do this. But yeah, if you, I think if you, let's see, if I leave out the comma or something, it can't do it, right? And then, so basically, it was very frustrating, and so Lubridate makes the conversions much easier when it's getting truncated here. But if you load up library Lubridate, all you have to do is say day, month, year, month, day, year. You just kind of put in the order in which the numbers appear, right? So we have 6th August 2005. That's day, month, year, like European form, right? And Lubridate understands that, right? And here we've got month, day, year written this way, and month, day, year written this way, and it understands both of them. Okay, no problem. It can handle that. So Lubridate really, if you're going to deal with date, excuse me, I'm going to cough here. If you're going to deal with the date information in your data set, I highly recommend the use of Lubridate, okay, to avoid headaches. Okay, is that all right? These are just some tips. Like, these are the products you need in your toolbox or cabinet, right? Go out and buy. Can you solve everything with just base R? It can be done, but it makes your life so much easier, right? Like, can you, I don't know, can you build a house with just a saw and hammer, and I guess that's all you need at the, probably, right? But it sure makes your life easier if you've got different special types of saws and drills and all of these specialized tools. And in the same way, with R, we can extend all of these things. Okay, questions on any of that stuff? We're all good? Okay. I'm going to cover this. This is called package rvest, and here we're going to be web scraping or harvesting from the web. Like, many of Hadley's packages are like plays on words, right? So he calls this rvest, and it uses Selector Gadget. Now, I go back and forth, on how important this topic is or not, right? Because other languages like Python is really useful for scraping the web for data. They've got, you got Beautiful Soup, and you've got all these other packages and stuff. And if you're going to be scraping the web, you might consider using Python. But I also want to say it is possible to do in R. And if you understand how rvest works, it actually makes our life quite nice, okay? And so what you would do is you would install packages rvest on your computer, and then you load it up. And it uses something called the Selector Gadget, okay? And this thing has been around for several years now. Last updated 2013, which is like 5 years ago. But it still works because the way we use CSS has not really evolved in terms of how the Internet's producing, like publishing HTML files on the internet. And so, so we've got that, okay? And let me pull up my RVest demo here, okay? So we'll load up library RVest. Let me clear out all of this. Okay, we're gonna load up stringer, and we'll load up data.table, okay? And so what we will do is we will go to this website. We're going to go to IMDb, and this is for this is the example that they used in the Selector Gadget vignette, and this is from the Lego movie. Okay, and so here's a website. And for the website, what you have to do is, I mean, the website might have information that we want to pull into R, okay? So for example, we might say, like, let's pull the title of the movie, or let's pull the movie rating, or things like that, okay? And the way we can get this is by using the Selector Gadget, okay? So on at selectorgadget.com, there is this little bookmark link, which is this little JavaScript thing, and you drag it to your bookmarks bar, and it shows up right there, okay? And so I'll go to the Lego movie, and when I click this link, okay, this little thing pops up on the bottom here, okay? And right now it says no path found, and then as I hover over different stuff on the page, like this little orange box starts popping around, right? So let's say out of this website, I want to extract this thing that says 7.8, okay? So if I click that, okay, suddenly a whole bunch of stuff gets highlighted, right? And this tells me that if I use this tag called span to select stuff, what it's going to do is it's going to go through the underlying HTML code and select everything with a span tag. So I don't know if you know how a website works, but you can click on any page. If you right click, you can click view page source, right? And it will show you all of the underlying code. This is what your browser sees, okay? When it talks to a web server, the web server sends all of this information back, okay? And the way your browser then takes all of this and it interprets it and creates it into something that's readable by humans, okay? And each, like, if you look through it, you can find like all of these things that say like coming soon and latest trailers and all of this box office. They appear somewhere on this website. I don't know where it is, but somewhere on here there's coming soon and latest trailers and all of this stuff, probably under one of the menus, okay? And these different things, there's like, I don't know if you can, can I magnify this? Okay, each of these things in these little less than greater than things, these are called tags, and there's like HTML tags, and all of these also have little classes for CSS. And so the browser, you define like how to display something. And so anyway, we see there's a tag called a span, okay? And this will take the piece of information, format it in a certain way. So anyway, okay, oh, there it is. Latest trailers coming soon, release calendar, all of that stuff, right? Okay, so those are the menus. So anyway, going back to the Selector Gadget, when we highlight something and we click it, it will tell us which tag it thinks we want. And it says if you select everything with a span tag it's going to select everything that's in yellow here. And we say, well, that's too much. I want this 7.8, but I don't want this thing. So I'm going to click this, all right? And so that causes, it says, okay, I think what you want is the dot ratings value span, okay? And it says you're going to get 3 things if you want that. And you say, no, I don't even want 3 things. I only want the 7.8. I don't want this. You have to kind of like, it suddenly becomes like a little bit of hide and seek. You got to find the other thing that's yellow. And then we'll say, I don't want that. So the box shows up red, which means we don't want it. And we click that, okay? And then, so this is the only thing that's selected. Clear shows there's only one thing here. And so this is just the one thing we want. And it says the way you select that is with strong span, okay? So I'm gonna just highlight that and click Control C. And this means in the HTML, if I search for strong and span, and we can kind of see that strong span, this gets the strong tag, and within the strong tag, the span tag, this will select this value 7.8, okay? And that's the thing I want, right? So if I search for strong and I search for span, this will pull that up. There's a few things with the strong class, or strong tag, but apparently only one with both a strong and a span. Okay, and that's going to tell Arvest to search for those tags and get us this number 7.8. Okay, and so inside R, what we do is we give it the URL, okay, which is, this is the web address for the Lego movie. And after loading Arvest, we say, use this command read_HTML, okay? And that basically reads in this file, reads all the HTML file into an object called Lego Movie. So now in our global environment, we have something called Lego Movie, a list of 2. And then to extract that, so if we just look at what Lego Movie is, okay, it's going to tell us it's an XML document, and there's a whole bunch of stuff here, okay? From that, we're going to say, from Lego Movie, select the node, the HTML nodes, that are classified using strong span, which is what we found out using the Selector Gadget. Using the Selector Gadget, we selected this thing, and we said we don't really want anything else. Whoops. We only want this, we don't want anything else, and so the way we're going to select that is by searching for the tags strong and span together, okay? So we go to R and we say, I want, take Lego Movie, and here we're using the pipe operator, right? So I'm going Lego_movie, which is this thing, and we're going to pipe that into HTML nodes, strong span, okay? And when we do that, it tells us that what we get back is an XML node set with one thing in it, okay? And so what we'll do now is from this, we are going to extract HTML, the text that appears there, okay? So if I say pipe the output of strong span into HTML text, then it pulls out the text that appears in that node, which is 7.8. And we want that as a number, so we're going to pipe that into as.numeric. Okay, and now we have the number 7.8. Okay, and then, so I have all of that written right here. And then we say take that result and store that into rating. Okay, so we do that, and we get back the rating 7.8. Is that okay? And so, you know, you can extract other things, right? You can use Selector Gadget, and maybe we want to get the Lego Movie, just the title, and it says, well, let's just see what happens, right? Let's just say select H1 and see what it pulls. Okay, it pulls out this whole thing, and so let's just take Lego_movie. And let's pull out the nodes. H1, and let's see what that pulls out. Okay, so it pulls out all of this stuff. There's quite a bit in there. Okay, and I think if we just pull out HTML text, it'll just be the Lego Movie 2014. Sure. Okay. Maybe we only want we don't want the other stuff. Maybe we don't want 2014. So then, you know, it's a little bit of guess and check. We might have to say like, I don't want. Okay, it's telling me no valid path found. No, we don't want that. Okay, so sometimes if you want to select one exact thing, it might be difficult. Okay, and that's just, you know, you play. You have to kind of select the things you don't want. Okay, so I might not be able to select just the exact thing that I want. Okay, but you kind of play around and you find the nodes or the tags that you want to extract. Okay. All right, you can extract more than one thing. So here we just extracted the rating to be 7.8. Over here, let's say, you know, more useful, maybe we want to get the cast list here. Okay, so using Selector Gadget, I can come over here and I can say, okay, I want to get Will Arnett, all right, and the name of the cast. So Will Arnett plays Batman, but we don't actually want to pull this stuff here. We don't want Batman, so let's see. So I'm just looking through. Is there anything else yellow that is selected that I don't want? Okay, this seems to do the trick. It says I'm selecting 16 things here, which seems reasonable. Okay, and so this is one way to select it. TD nth child 2A. So apparently, in the table tags, we can pull out the information that way. Last time I did it, I used title cast item prop span, but we can just use what I did. Lego Movie. Sometimes you click it and you get different things, and it's just like different ways to select the same thing. Okay, so I'm going to say HTML nodes, and we're going to put in the kind of the path that Selector Gadget selected. Okay, and then I'll go ahead and just run that and take a look, and it pulls out 16 nodes, which is what I want. And then I'm going to just say I want just the text from there, HTML text. Okay. And now it returns. Okay, so now it returns what I've selected, but it's got some white space. Okay, so maybe along with Prime Video Unlimited Streaming, maybe it selected some of the stuff. So here, I might pipe that into strip white space. How do I do that? String R, string R trim. Okay, so I think this will remove all the white space. Okay, so using from string R does text processing, and str_trim trims off the additional white space, which includes leading spaces, and then /n will be new line characters. Okay, and so now I've successfully extracted the cast members here. Okay, using the Selector Gadget. Okay, with the exception of number 16, Prime Video Unlimited Streaming. Okay, last time I did this, I used title cast item prop span, and that gave me the cast list. Let me just see if that still works. Oh no, it didn't work this time. Okay. So I will use this now, okay? So sometimes, okay. So we'll do this, and we'll do this. String trim, and then cast. What I'll do is I'll just say take the first 15 values. Okay, and then so here, cast is these 15 actors. Okay. So here we're pulling the information out here. Okay. Is that okay? Are there any questions on this? How this is working? Okay. Other things, I think, so I was playing around with it, and we can pull out even like the URL of like the poster. And so if I did this, I think, no, this is not working anymore. Okay. So inside a tag, so let me select this, and we'll undo that. Okay, so this says, okay, so let me just select this. And the way images are stored in a website is that there is an image tag, but then the location of the image is given a SRC, kind of a resource location, and that's how it locates the thing. So, so I'll use this, and when from the node, so let me just kind of show you what happens. So when you extract just the node using what Selector Gadget selects, it pulls all of this out, but the aspect that we want is the source. So we're going to pull out the HTML attribute that says SRC, the source of the image. Okay? And when we do that, it gives me the web address of the image location, which is stored right here at mediaamazon.com. Okay? And by going to that website, or going to that URL, it pulls up the image, the image that's being displayed on the page. Okay? And so here I can use this and then pull out the web location of this thing. Let's see what this is. It's always risky going on some random URL here, but let's see. Okay, this is a screenshot from the Lego movie with Space Guy and Batman. So, so there you have it. So you can pull out not just the text, but you can pull out different HTML attributes. So within the HTML tag, there's all these different attributes that you can then extract. Okay. So those are different ways to do it. Okay. Again, everything within Lego Movie on this web page you can kind of pull out. So this person gives a Lego Movie 6 out of 10 stars and says somewhat overrated. Okay, I'm gonna find a review that I like. Okay, well anyway, all right. Let's just say we're gonna pull what this review has to say. And then we'll click that, and it says it's selected a whole bunch of other stuff. So here's you just got one thing, and it'll use title, users, reviews, teaser, P. That's how we are going to select this text. And let's see. Okay, so that's what we do, and then we pull, we just run it through HTML nodes, pull out the text, and then from review, it pulls in, oh, it's getting something different. Somehow, when I went to the web page, it pulled a different review. Okay, this is my first review. Okay, but anyway, so there we have it. Okay, so you can use Arvest to go to a web page and extract information from the website and pull it in. Okay. And I think this next part is truly amazing. Or I don't know. I'm impressed by simple things, so maybe this is not that amazing, but I think it's amazing. Is that sometimes you want to pull not just information from one web page, but you want to like start off on a web page, and then you want to like click links, right? And you can say, oh, Will Arnett, he's the voice of Batman. I like him. Okay, so we'll click him, and we'll see where this takes me, right? This takes me to Will Arnett's page, and he's Canadian American, and we can learn about the other stuff. And they're making a Lego Movie 2, the second part. Oh my gosh, I'm so excited. And then he's also in Teen Titans Go to the movies, and Arrested Development, and Show Dogs, and you know, we can look at his filmography and see all of this stuff, right? And so maybe we want to pull some of the information from his page, right? This is not available on the Lego Movie page. Lego Movie just tells us who these actors are, and then each individual actors, right? So maybe we're interested in Elizabeth Banks, okay? So we click Elizabeth Banks page, and we can see, okay, she was born in Pittsfield, a small city in Berkshire in western Massachusetts. Okay, that's great. And then we can see, you know, what movies is she in? And they're making another Charlie's Angels. Okay, that's interesting. And anyway, all of these things that they're doing, right? And she was Rita Repulsa in Power Rangers. Okay, and so anyway, we might want to visit these different web pages. So in R, we can do this, okay? And it's called creating a session, okay? So when you go to a website, what your computer does is it establishes a session with the server. So the server is a computer somewhere else in the world that has the information that you want, right? And your computer establishes a session with the server and says, give me the information I want. You click a link and it says, I'm going to request this thing. And the server says, okay, my wish is your command. Here you are, right? And then you say, oh, I want to go to, I'm on this page and now I want to go to this thing. So you click the link and it tells the server, I want this thing. And the server sends the information back to you, okay? And that's how we normally go around the internet, right? We click links, we read stuff, we go, ooh, that's interesting. We watch a video and we click links and we, you know, waste our Saturday afternoon doing that. We can do the same thing within R. R can set up its own session, okay? And it will start, and we don't, it's different in that the session exists within R, and it's not rendering the web page for us to view like a web browser. So your web browser takes the information from the server and turns it into something that you can see on your screen. When you create a session in R, it doesn't turn it into something you can see on the screen, but R is still getting that same information. And so you can tell it to, you know, click links and go to other pages. So for example, instead of just saying read in the HTML from one website, we're going to tell R, establish a session, okay? So I clicked that, and S is now, it says list of 7, but it tells us that it is a session, okay? Status 200, which is kind of like normal, okay? Like status 404 is like it couldn't find the web page and stuff like that. But here we've got a session established, okay? And then, so we don't get to see the page, but basically R is visiting this page just like us right here. And on this page, there's a link that says Will Arnett, right? And so you could tell your friend, oh, are you on the, you can imagine being on a phone conversation with your friend. You're not allowed to see what's on the screen, but you can say, oh, are you on the Lego Movie webpage? Okay, go find the link that says Will Arnett and click that because I want to see what Will Arnett's up to. So you say, okay, we're going to do that, right? So we click Will Arnett and we go to Will Arnett's page. And we can tell R, do the same thing. So we can say starting at your session, which is S, which we've created using here HTML, we're storing that as S, our session. We're going to say follow the link Will Arnett. Now when I do this, this will end up being another session, okay? So it says navigating to this, and we're at, what it returns back is a new session, or is just another session located at this web address, okay? And if we copy this web address, this indeed is Will Arnett's page, okay? Which it should be, right? Okay, but what we want to do stuff with Will Arnett's page, so we're going to say read the HTML, and let's store the result of that into something called will page, okay? And so now Will's page is an HTML thing, an XML document, and we can apply the same type of thing, such as before. Now that we are on Will Arnett's page, we can say, you know what, I want to know what movies Will Arnett is in, right? So I'm going to say, let's do Selector Gadget, and let's select his list of movies. This is too much stuff, so I'm going to unclick that. Now it's not enough stuff. I don't actually want that. I want this, okay? So I want 241. Is that too much? He's in a lot of stuff, as he should be, but let's see. It sure seems like a lot. Am I selecting too much somewhere else? Okay, I don't know. Okay, but we're going to select tags B and A. All right. So that's what we'll do. Okay, so we'll select this. He was in The Office? Fred Henry? Search committee? Got to rewatch that episode. All right. So we'll do that, and so we can say, all right, from Will's page, what we want to do is select the nodes B, A, and then let's just take a look at the text in those nodes, okay? And when we do that, this looks exactly like what we want, right? Starting off at the very top, showing all the different things. The Lego Movie 2, Teen Titans Go to the Movies, Arrested Development, Show Dogs, A Series of Unfortunate Events, Hot Date, The Magic School Bus Rides Again, and BoJack Horseman, all of that stuff, right? So this stuff happens, and so maybe we want to just say, like, let's take kind of the first 10 movies, right? So we can say head 10, and this will just do the kind of the first 10 movies that appear, right? And maybe we want to extract a whole bunch of stuff. So I think we're going to look at the years, and yeah, we'll just do that. Okay, so we'll pull out the name of each thing, and then using Selector Gadget, we'll pull out the year of these things. And I think this is all we want. Okay, and so we're going to just extract year column, and that's fine. Okay, and so I guess when I did this, I did filmography year column. So if I ran this through, let's just see, from Will's page, feed that through. Oops. Okay, it's pulling the years of each of these things. Okay, which is what we want. Okay, so now that I've established a session, what I can do is I can remember earlier from the Lego Movies page, we extracted the cast list. And so we have Will Arnett, Elizabeth Banks, and Craig Berry, Alison Brie, okay? And we can use this now as a way to give instructions to the session in R, and we can say, follow the link that says Will Arnett, pull out this information and come back, okay? After you went to Will Arnett's page, I want you to follow the link that says Elizabeth Banks. After you do that, I want you to follow the link that says Craig Berry, so on and so forth, okay? So what I'm doing now is I'm building a loop, okay? I'm going to create an empty list called cast_movies to store our information. But what I'm going to say is for the first 3 items in cast, so in cast is all 16 of these actors, we're going to say for cast 1 through 3, so we're going to do this for Will Arnett, Elizabeth Banks, and Craig Berry. What we want to do is we're going to start at our session, the session which is currently at the Lego Movies page, right? So S is at the Lego Movies page. We're going to follow the link that is Will Arnett. Then we're going to follow the link for Elizabeth Banks. We're going to follow the link for Craig Berry. Okay, so we're going to say follow the link, and after you follow the link, read in the HTML. Okay, when you read in that HTML, store that as the actor page. Now that you have stored the actor page in memory, I want you to do these things. I want you to extract the movies that actor is in. So we're going to go to actor page, select the nodes BA, because that's a way to select the titles of the movies, extract the text, and give me the first 10 that you see in that list. Okay? Also, while you're at the actor page, select the nodes filmography year column. And I think, well, let's just make sure. This works for Will Arnett. So Will page. Keep doing this. Okay, so pull out the nodes with the year, and then extract the text. Okay, which does this, and from there, we're going to ask for the first 10. Okay, which gives me the first 10 years. And then here I'm using a regular expression which we haven't covered yet, but this regular expression says I want something that is made out of the digits 0 through 9 and has 4 of them in a row. Okay, and so that will search this thing and it'll ignore the white space and it'll say, oh, here are 4 digits in a row, and it'll give me 2019. And that will also take care of these issues where I've got something like 2003 to 2018. It's going to just take the first 4 that match. So when I feed this thing, which is currently producing stuff with ranges, and I feed it into this, and I say, from there, extract something with the digits 0 through 9, and I want 4 of them in a row, then it pulls it out. Okay. So even though this is a range 2003 to 2018, it just pulls out the first 4 digits that it finds, which will be 2003. Okay, and so we say take that and store that into cast movies $years. Okay, so here we're creating a list, and the list is going to be have kind of 2 levels, right? Cast movies double bracket I says create a train car called Will Arnett. And within that train car Will Arnett, we're creating an additional list using the $. And so within the train car Will Arnett, there's a train with 3 things in there. A movies train car, a years train car, and a name train car. Okay. Inside the name train car is going to be a vector with the length cast movies $years, which is just going to be Will Arnett I repeated for however long cast movies $year is. So it's just going to be something of the same length. Okay, and when this is done, it's going to go back and it's going to go to the next thing in cast 1 through 3, which if we look at cast 1 through 3, the next thing is Elizabeth Banks. So it's going to go to Elizabeth Banks webpage, extract out the HTML, and then create a new train car called Elizabeth Banks. And within that train car is going to be a train with movies, years, and name. And it'll populate all of that. Okay? And then once it's done with that, it'll go to Craig Berry's page. It'll create a train car for Craig Berry and extract all of that information. Is that okay? What's happening in this loop? So I'm going to go ahead and I'm going to run this loop, okay? So it just says cast 1 through 3. For each of these things, pull out that information. So it's running. It went to Will Arnett's page, it went to Elizabeth Banks' page, it went to Craig Berry's page, okay? And then let's take a look at the cast movies list, okay? So if I do structure of cast movies, what will it be? A list of 3, right? Will Arnett, Elizabeth Banks, and Craig Berry. And each of those things themselves is a list of 3. Will Arnett's list is a list of 3 movies, years, and name. Elizabeth Banks is a list of 3 movies, years, and name. Craig Berry is a list of movies, years, and name. Yes, question?
So if you had like poor internet connection, like pulling up a web page might be slow.
Uh-huh.
If you have poor internet, would all this be running slower as well?
Yes, because it requires, because you basically have created a it's a web browser within R, and the web browser inside R is talking to the server. Okay, so it's all client side speaking to the server. We're not doing anything on the server. We're just asking the server for the information. Okay, so yes, if your internet speed is slow, this thing will run very slowly. Okay, it'll take however long it takes to visit the web page. Okay, but here, let's take a look at the list that we've produced, and it's exactly what we want. So on Will Arnett's $ movies, we have Lego Movie 2, Teen Titans Go, Arrested Development, along with the years associated with each of those things, 2019, 2018, 2003, and then I've got Will Arnett repeated a whole bunch of times. Okay, and so what I can do now, and then we have the same thing for Elizabeth Banks, Signal Hill, Charlie's Angels, Lego Movie 2, and then Craig Berry, Toot and Puddle, Lego Movie Mischief City, and all of this stuff. We can merge them all into a single table using this command rbindlist, okay? So this is kind of like creating a data frame, but it requires, the inputs have to be very specific. You need to have multiple lists, all of the same length, and then the structure of each things have to be the same thing, right? So if I do rbindlist cast movies, we have now, we produce a table with, I think, what we're looking for, okay? The Lego Movie is the year 2019 with Will Arnett, Teen Titans Go, 2018 Will Arnett, so on and so forth. Signal Hill, no year available, Elizabeth Banks. Is that correct? I'm curious. Yeah, Signal Hill has no year available. So, so that's what we have, and all of this stuff, right? Is this cool? I think it's pretty cool. All right, and so I just want to warn you, right? Like, so in your homework, I give you an exercise. You know, if we wanted to, we could, instead of doing just the first 3, we could do it with the first 10, and you'll see it takes a while because we got to visit 10 websites now. So it's going to the first one, it's going to the second one, third, fourth, and it's following each of these things. And for all of that, and let's just rbind it, and we've kind of pulled the first 10 movies for each of our actors: Will Arnett, Elizabeth Banks, Craig Berry, Alison Brie, and we can kind of see what's going on. David Burrows, Anthony Daniels is C-3PO and just does a bunch of C-3PO stuff. Okay, so anyway, you know, we've successfully done this, right? Will Ferrell is going to be in a movie called The 100-Year-Old Man Who Climbed Out the Window and Disappeared, which sounds compelling. Okay, so anyway, we can, thus set up an automated thing to kind of follow links, okay? And so you can do that with Arvest. And I'll post this code, this Arvest demo code, which I think will be useful for your homework. So this week in your homework, you will be using this. Yes, question?
Is there a way to just follow all the links?
Follow all the links. Probably. Okay. So what you need to do is you need to give our instructions. So if we look up, but it's not going to be an automatic. You got to specifically tell it, right? So if we look up the function follow link, okay, we can see the way it looks up. So you have to say you got to create a session and then the URL, right? And you can select a link, follow a link to using an integer, and it selects the ith link, or a string, which is the first link containing that text, right? So we use the string method. We said find the text Will Arnett and follow the link that says Will Arnett, right? But if you have a link like you're gonna do, there's a link that says go here or something like that, right? And you've got multiple links on the page that says go here, then it's only going to just pull the first one, right? So if you want to follow all the links, you can give it an integer instead, and you can say follow the ith link. But you'll need to figure out how many links exist on the page in the first place. So maybe using Selector Gadget, we can turn on Selector Gadget, and I can just do A, okay? So most links are created using an HTML tag called A for anchor, and that's how links are generally created. And so we can say follow everything with an A, and this tells me there's 599 of them, and we can tell for I in 1 through 599, follow the link. For follow link 1, follow link 2, follow link 3. If you do that, the server might get angry, okay? The server might say, what is going on? I've got this session, and this guy is repeatedly making requests, okay? And some servers might kind of block your IP or give you a timeout or something like that, because a lot of servers will have these defensive mechanisms set up, right? Because not everybody on the internet is nice and innocent, right? And so people try to do these like DDoS attacks, and we'll say, or like we'll just throw like a bajillion requests at a server, and depending on how strong the server is, it might not be able to handle all those requests, right? Amazon's webpage, their front page can probably handle a ton of traffic, right? But the UCLA Stats Department webpage, the server is running in a closet in the Stats Department, okay? It's a computer that's set up so that when people say, I want to see the Stats Department website, they're talking to a computer that's stored in a closet, right? I mean, it's air conditioned and set up, and it's pretty nice, and it can handle a decent amount of traffic, but it's just, one computer. Maybe I'm giving too much information away here. And so like, if the whole world decided it wanted to hit the Stats Department website, it's not going to be able to handle that kind of traffic, right? And so a lot of servers have these defense mechanisms set up that say, hey, this guy keeps making requests, like 20 requests a second. I don't know if I trust this guy, and they might try to block your IP and stuff like that. So So in general, play nice, okay? Play nice with the servers. Don't spam requests, okay? When you run a loop, okay, you only need to run a loop for like 3 things, and if it works for 3 things, it'll work for 30 things, okay? If it runs for 3 things, it'll work for 100 things. And so let's say there's 100 links you want to follow. To test it out, you don't need to say follow all 100 links. Just say follow for the first 3. And if it works for the first 3, then you're in good shape, and then you can run it for all 100, okay? But while you're testing it out, you probably have to repeatedly try out your loop over and over and over again. And so just request it for like the first 3, okay? You don't need to do it for all 100 every single time, okay? And and if you do that, that will take a lot of your time as well. So I don't know. Does that make sense? How that works? Any other questions? Yes.
You ran it in a while loop with like an inappropriate stopping condition, just spammed it like infinite times that possible. Other than the fact that it probably blocked your IP.
Yeah. I mean, whatever. If you want to wait for an infinite while loop, then and the server is happy to continue giving information to you, then it will, right? I mean, that's pretty much how a DDoS attack works. Is just it runs these infinite loops of continue making requests, maybe change the request a tiny bit, so it has to give you something new every single time. And what they do is they just take a whole bunch of internet connected devices and aim all of its traffic requests at a server at a time or something like that, right? So I think the most recent one, not the most recent one, but like a major significant one was these guys wanted to crash each other's Minecraft servers because apparently there's a lot of money in Minecraft servers. You can ask people to sign up for some premium access to your private Minecraft server. And in order to kind of like kill the competition, what they did is they infected a whole bunch of like internet connected like web cameras and stuff like that. And those things can make requests, and they infected it with malware. And then they said, all right, every single internet connected camera that we've infected, and there were like millions of them, everybody make a request of this Minecraft server, and it would totally just bring down the servers. But it was like so powerful they could just bring down like major websites, right? Like major shopping websites and stuff. And anyway, they got caught. And that's why I'm telling you this story. They're being tried in Alaska. I don't know why. But okay. Anyway, so we've got that. That's Arvest. Pretty great stuff for doing this. Extracting information from HTML is a little bit older. A lot of times APIs now exist, okay? And we're not covering that in this class, okay? But and probably if you're doing APIs, most of them talk a little bit better with Python. So if we're interested in APIs, you can look up. Well, anyway. But let's continue on in our lecture. And let's talk regular expressions. And I'm going to get into Stringer. But are there, I guess before I do that, I just want to make sure if there's any other questions. Okay, so Stringer and regular expressions. So have any of you guys used regular expressions? Like a few of you. Okay. Regular expressions are a way for us to kind of manipulate or pull information out of text. Okay? So you might have a whole bunch of text in a document, and you might need to pull out anything that looks like a phone number, okay? And so there's regular old searching, right? So in Microsoft Word, you're writing up something, and you can always do find and replace. You hit Control F, and you can say like, find all instances of the word UCLA, and it will find UCLA in your document and stuff like that, right? But what if you have a bunch of text and there's a bunch of phone numbers in there, right? And you want to say, okay, find anything that looks like a phone number. Or I want you to find anything that looks like, and better yet, I actually just want the area codes or something like that. Now, how do you tell the computer, I want just the area code? Okay. We need to have something that has what we call meta characters, okay? So we need to say, computer, search for things that look like digits. Digits are the numbers 0 through 9, right? And an area code will, at least in the United States, has 3 digits, okay? But we can't just tell the computer, search for 3 digits, because you might have a street address or a zip code, right? And you don't want it to pull up like 900 and say that's a area code, okay? So you need to tell the computer, okay, you got to first find something that looks like a phone number. A phone number is 10 digits long, okay? And you got to, and probably maybe it has parentheses, maybe not, I don't know. You got to kind of tell it, like, find something that's 10 digits long, not more than 10 digits, but exactly 10 digits. And then within that, the first 3 digits are going to be an area code, okay? And for something like that, Microsoft Word's search function is no longer powerful enough, okay? You need to give it something else. So we have regular expressions to kind of step in and take on this task of searching for things that are a little bit more general, rather than saying this specific sequence of characters, which the search function currently does. We want to say search for certain patterns of characters, and that's what regular expressions do. And we've R can handle regular expressions using grep. There's a grep, which is kind of a tool from Unix, and that exists already in R. But I really recommend using Stringer. Okay, Stringer is a package coded up by Hadley Wickham. It's excellent, and it kind of, I would say, beefs up grep and formats the output of your regular expression searches in a way that I guess it creates these kind of vectors or lists that we can then use and manipulate. Okay, and you can read more about this on the Stringer vignettes, and you can pull all of this stuff here. Okay. Okay, so the functions within Stringer, we have string detect, string locate, string extract. Okay, probably the ones that we would use are string extract. Further on, we got like string match, but you detect just says, did we find this thing? Yes or no, true or false. String locate is, did you find this thing? If you did, where did you find it? Okay, I found it at the 87th character. Okay, string extract will say, did you find this pattern that looks like a area code? If you did, what were those numbers? Okay, the numbers were 213. Okay, that's what string extract does. Okay, string match says you can establish things called matching groups, capture groups, and it could be like a phone number we're going to break up into an area code, a prefix, and a suffix. Okay, and you can say, did you find this thing that looks like an area code? Yes, I did, and I pulled it out, and and you say prefix and suffix, and it can pull those out, and you will get 3 separate answers for that string pattern, okay? And then you can refer to each of those answers separately, okay, with string match. String split will take a string and then split it up. String replace will take something, find the pattern, and then replace it with something else. So maybe you want to, I don't know. I think we're familiar with find and replace in Word, and you can do something like that with string replace, but it's expanded with the regular expressions. So you can say find all things with area codes and replace them with area code 800, and we'll turn them all into 1-800 numbers or something like that, right? I don't know. What if we take everything with a web address, .com, and we replace it with .edu or something like that, right? And now we have Amazon University or something, okay? So we have that. All of these current in this form, we'll just find the first match and do the operation on it. But there's also like string match _ all, string extract all, and these will work for not just the first, but all the matches inside the block of text. Okay. Okay. So here, this is a vector. Okay. So students sometimes get confused because I have 2 examples that use the quick brown fox jumps over the lazy dog. And in my first example, I have a vector of the words the, and the word quick, and the word brown, and the word fox, and so on and so forth, okay? And then in the next set of examples, it's just one string that says the quick brown fox jumps over the lazy dog. Okay, so here I've got a vector of words, and we are saying, do you detect the string pattern quick, Q-U-I-C-K? And it says, no, that didn't exist here. It did exist right here. It doesn't exist here, and so on. So it gives me false, truth, false, false, false. Okay. Did you detect the string O? Okay. And inside this vector, it gives me false, false, true, true, false, true. So it finds it in brown, fox, and over, and dog, and stuff like that. Okay. Simple enough, right? Okay. So again, the patterns that make regular expressions more powerful, rather than just searching for literal text matches, which this is what the find function in Word does. It just finds the exact character matching. We can expand the power of searches using meta characters, okay? And these meta characters are things like the dot and the caret and the $sign. All of these things take on special meanings, okay? So you are not allowed to search for a parentheses, okay? You can't just say, tell me, did you find a parentheses in the text, okay? If you want to search for a parentheses or a square bracket in the text, you have to explicitly tell R that I want to search for the literal square bracket character, okay? Don't use its kind of pattern meaning, but I'm looking for the literal square bracket character, and so you have to escape that with a slash, a backslash, okay? However, the backslash itself is a meta character, so in R, at least, you have to use a double backslash, okay? So if you want to search for the literal square bracket, okay, you have to say search for double backslash square bracket, and it will say, did you detect a literal square bracket inside ABC square bracket DEF? And it will say yes, okay? If you give it just this square bracket by itself without the double backslash, it's going to say there was an error, missing closing bracket, because it's taking the meaning of the square bracket for something else, okay? In other languages, sometimes you just use a single backslash, but in R we have to use a double backslash, okay? So you'll see these double backslashes here and there, okay? Okay, we have anchors, which refer to the start or end of a string, and also we have word boundaries, okay? And we have slash little b for a word boundary and slash big B for non-word boundary. And you'll find a lot of these meta characters, okay, are slash lowercase letter for that thing and slash uppercase for not that thing, okay? So if you want the word boundary, it's slash little b, and if it's not a word boundary, it's going to be slash capital B, okay? What is a word boundary? A word boundary is basically when you read a sentence and we know that we have the start of one word or the end of one word and the start of a new one, like a space, that's a word boundary, right? Also, right here, there's a word boundary from for and normal strings, and this is not, at least in the rendering of this is a new line character, okay? It tells the computer to take the next word and put it on a new line, okay? Your word processor, when you type out words, we're accustomed to this, is that when we type out the word for normal strings, the word processor automatically says, oh, you've reached the end of a line, and I'm going to put the next word on the new line, right? But if you think about if you had an old-fashioned typewriter and you had to type everything out, when you type in the word for, you're looking at the page and you're like, oh, the word normal is not going to fit there, so you don't actually hit space on your keyboard or on the typewriter. You have to hit enter or carriage return, and it brings it over to the other side, right? So, and it's actually two things. It's a new line, so you advance the paper up like a 1/4 inch, and then carriage return, which is the part where you slide the typewriter head all the way to the left, right? So there was, like if you watch movies of people typing on the typewriter, there was always two things, right? They reach the end of the line, it goes ding, they hit enter, it causes the page to advance like a 1/4 inch, and then they have to carry that thing and push it all the way to the left. And so we have lost sight of that because we never do it anymore on the word processor. But the computer's doing two things. It's creating a new line and it's doing carriage return, because when they were coding this up, typewriters existed and they basically put everything that they do in a typewriter into computer form. So anyway, those are word boundaries. Spaces before and end of a word, new line characters, carriage returns, those form word boundaries, okay? So now this is a single, it's not a vector of words, it's just a single character thing. And we're saying, did you find this pattern in this character text? The quick brown fox jumps over the lazy dog. Here, the caret is the word anchor for the start of a string. And so this says, do you find the start of the string and the word the, and replace that with a dash, and it replaces it right there, okay? What about, look at the start of the string and find the word dog, and replace it with a dash? Well, it looks here and it says, I don't find that exact match. I find a space dog, but that's different. So nothing gets replaced here, okay? What about, do you find the and the end of the string, end of $sign is the end of the string. Do you find the at the end of the string? No, nothing gets replaced. Dog followed by the end of the string? Yes. Okay, it matches that. Okay, again, /A will be the start of the string, okay, and /Z is the end of the string, okay. Boundaries, we've got /B for word boundary, and so here, what about word boundary jumps word boundary? So this means, do you find replace a word boundary? So the word boundary is not the space, but is the word boundary itself. Okay, so it's different from find space jumps space. Okay, space jumps space would replace the spaces around the word jumps. Okay, but this is word boundary, which says It's the start of the word and the end of the word, but not the actual spaces. So it replaces the word jumps with the dash here. Okay. Here we've got word boundary jump, word boundary. Okay. This does not find a match because it will match the word boundary JUMP, but P is not followed by a word boundary. It's followed by an S. So there's no match here. So that's why nothing gets replaced here. So far, okay? All right. Here I've got capital B, UMP, capital B. So non-word boundary, UMP, non-word boundary, and that finds a match right here in UMP. Okay. Non-word boundary jump, non-word boundary, that doesn't find a match because J is preceded by a word boundary. So there's no match there. Is that all right? Okay, so those are word boundaries and anchors, start and end of strings. We have other things. We've got special character classes, okay? And so you'll notice the pattern of the lowercase versus the uppercase. You want white space, that's /s, okay? So that's anything that includes both a breaking and a non-breaking space, which to our eyes are invisible, but the computer distinguishes the two. Okay, maybe you are familiar with what do you guys know what a non-breaking space is? Maybe, maybe not. Okay, so let me just kind of demonstrate. So normally, when you type out, say, I love UCLA, I love the city of Los Angeles, okay? It is the greatest. All right. So let me, we've got this, right? And so, so this is normally, why am I not able to zoom here? Okay. As I'm typing here, so if I write, if I write I love, and something like this, it knows to take, it sees the space between Los and Angeles, and it will put Angeles on the next line, all right? I love the city, and if I hit space, it pushes, it recognizes when a word, two words are separated, because there's a space here between Los Angeles, and this tells Microsoft Word that you can put one line onto another, right? But somebody might say, we are not like Los Angeles. You cannot put Los on one word and Angeles on another word. That's not allowed. That looks funny. So you can put in Los _ Los Angeles like this, and this will keep the two together, right? I love the city. And it will keep them together. But you're like, I don't want this underscore nonsense here, right? So in Word, you can, I think, Control-Shift-Space. Let me just see. Okay, so we have regular dots to indicate spaces. So this is a regular space. Control-Shift-Space puts in a non-breaking space, okay? So I'm going to turn off the hidden symbols, okay? And it looks the same. It looks just like Los Angeles, but now, if I write something over here, right, it keeps them together. It will not separate Los Angeles here, right? So if I put in love, if I love the Los Angeles, it keeps those two together. Whereas if I get rid of the non-breaking space and I put in a breaking space and I type in love here, it will split Los and Angeles, okay? So the difference is the breaking space allows the space to be broken across two lines if it reaches the end of the text in a word processor. A non-breaking space says, treat this as if it were like an underscore, so it keeps the whole thing together. But of course, you don't want to actually see the underscore. We want it to look like a space, but don't you dare put them across two lines. Okay, don't split those up. Right? Is that okay? Of course, when you're looking at the text, you have no idea. But the computer knows the difference between the non-breaking space and the regular old breaking space. Okay, but anyway, in regular expressions, it will recognize white space, both breaking and non-breaking spaces, as white space, and you can say, I want you to get rid of white space, right? I want you to get rid of everything that looks like a space and delete it, okay? Or something like that. And then if you want anything other than white space, you use capital S. You want digits, you use little d. Anything but a digit, capital D. Word character. Word character is the letters, the alphabet letters A through Z, capitals A through Z. Also digits and also underscores. So basically, things you can put in a username, right? Like if you're going to create a username for a website, and you want to be like Mr. underscore nobody or whatever, 005. Those all count as word characters, okay? And if you want anything but word characters, it's /W, okay? /W, okay? So spaces are not word characters. You can't put spaces in a username for a website. But pretty much most websites will just say, is the username consisting only of word characters, A through Z, 0 through 9, and underscores. And that's pretty much what's allowed in a username, okay? Okay. If you want something more specific than just regular old digits and characters, you can specify ranges of characters, okay? And these are using square brackets. Square bracket ABC says match the character A, B, or C. If you want to say anything but those characters, you put in a caret there, okay? If you've got, if you don't want to list off all the letters, you can say A through Q, okay? And you can do this, so you can imagine like some kind of searching for a serial number or whatever, and you know what range is available. You can say the digits A through Q, or uppercase A through Q, the digits 0 through 7, okay? The dot is a dangerous character, okay? And this will match everything, okay? This matches everything except the new line character. Okay, so this is like dot. Dot will do everything, okay? Maybe I'm doing too much all at once, but we'll do some examples here, okay? So basically, all I'm telling you is you can do characters, classes of characters, specific ranges of characters, okay? And then we can do quantifiers. Quantifiers will tell you how many you want to match, okay? So maybe we saw this, the quantifier, curly brace, and a number. We saw this for matching a year. Matching a year, we said we want the digits 0 through 9, but we want 4 of them. And that's how we know it's a year, right? At least years that will exist in IMDb. And we use curly brace 4, right? Of course, you know, years could only have 2 digits, right? The year 20 BC or something like that, you know? Like, except if you didn't see that BC or AD or BCE or whatever like that, if you see the number 20, your mind is probably not going to be thinking, oh, we're talking about the year 20, right? Because we're so accustomed to seeing years as these 4-digit things, right? If you see 1851, you'll think probably the year 1851, right? We kind of have this, I don't know, mindset of what years are accustomed to, right? I don't know. Okay, anyway. So you can say, I want to find this, okay? You can also say, I want 0 or more, star. Dot star is like super dangerous because it'll match like everything. Any character is the dot, and star is like 0 or more. So match like any or all, okay? Plus will mean match 1 or more. You've got to find at least one of those things and any more of those. And then match 3, exactly 3, 3 or more, 3 to 5, anything from 3 to 5 inclusive. Question mark is 0 or 1. Oh, we're getting. Okay, let's stop and do some examples here. Or do I have the examples later? Let me just find. Okay, so let's play around with this. Okay, it's 240. I used to make you guys do this in your homework and put this on exams. But I think for the summer, I'll take it easy and not test you guys and not put this in the homework. However, I think regular expressions are so awesome and so powerful that I do want to cover this, right? So we'll say this is our string. The quick brown fox jumps over the lazy dog. Okay, and let's do our pattern. The pattern will be THE. Okay, so let's do string replace, and we'll take the string with the pattern, and we'll replace it with a dash. What will it return? I'll show you. Okay, oh, I'm sorry. String replace only does the first. It finds the first character in here that matches this pattern, T, H, or E. This says find one of T, H, or E and replace it, okay? Let me do string replace underscore all. String replace only does the first one. String replace all will replace all of them. So here it says find T, H, or E, and it says I found it here, T, H, E. So we get dash, 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 and then it finds a match with the E and over and replaces with the dash, and it finds a match with T, H, E and does dash, dash, dash here, okay? This pattern is exactly the same if I write it like this, okay? EHT, if I say this is the pattern, okay? Because it just says any one of these, because the square brackets say find any one of these characters, okay? And so this will return the exact same thing, okay? If I just did T, H, and E, H, and B, then it will keep the T's and replace each of them with an H and an E and something like that. Okay. Is that okay? What's going on here? Let me so I got A, E, I, O, U, and let's find W. Okay, what will this match and replace? No. This is just the literal character W. Okay, so here's the text. The quick brown fox jumps over the lazy dog. Here's the pattern. So find any A, E, I, O, or U, and it has to be followed by W. So it's only going to find one. Okay, it's going to find O, W in brown and replace that. Okay. I can do, I could put in W or Z. And what's that going to match with? Will it find a match? It'll find brown and lazy. Okay, it'll find the OW in brown because it's one of these characters followed by one of these characters. OW matches and AZ. One of these characters, the A, followed by one of these characters, the Z. Okay, what about this? Bracket AEIOU followed by bracket W through Z. Okay, so it'll replace the OW in brown, the OX in fox, not the OV. Let's see, UI, no, IC, no, OW, OX, yes, UM, no, OV, TUV, no, okay, ER, no, E space, no, AZ, yes, OG, no, okay? So we'll get that. Brown, ox, lazy, right? Did I do something else? No, right? And then if I throw in G and then W through Z, it'll get the dog or something like that. Is that okay? Let's see, what else can we do? Let's do AEIOU followed by white space. Well, will this match anything? Oh, I got to do /S, sorry. The E space in the, right? It'll match that. And E space in the here. Because it's any one of these characters followed by white space. So we got the quick brown and the lazy dog, the E space, right? If we didn't want to replace the space, I can do word boundary. Okay, and it'll replace the E in the and the E in the over here. And if I did a capital B, then what will it replace? It'll replace all the vowels except for the E's and the. Okay. And the Q dash dash. Okay, so it replaced all the vowels except for the E's and the. And stuff like that. Is this confusing or is this okay? Oh my gosh, it's 2:48. Okay. I didn't even get to do quantifiers. Okay. Greedy and ungreedy matching. Okay, so if you do a dot star, okay, so this says, all right, so if I do this, and I say find a match and do it, it's going to find two vowels in a row, right? So it's going to find only the Q, UI in quick, right? Okay, if I do dot star, this will say any and all and everything in between. And then it says, okay, I'm going to find the first vowel and everything in between until I find the last vowel. And it's going to take out everything in between. And so we're left with TH and it finds the first vowel E and it finds the last vowel O and it replaces everything there with a dash. Okay, that's called greedy matching. It's tried to do as much as it possibly could. Finds the first vowel, the E and the, finds the last vowel, the O and dog. You put in question mark that says, hey, don't be so greedy, okay? Just find the smallest thing that matches, okay? And now it has to say, okay, let me find, oh wait, this is, E, oh, I'm confused. it goes all the way to the O and brown. Why is it going all the way to the O and brown? Fox jumps, that makes sense. Okay. I don't know why it doesn't stop at U right here. Oh, no, it does. It does. Okay, I got confused. Okay, so it makes sense. There's 2 dashes. That's why I got confused. Okay, so what it does here is it says find the first vowel, E, followed by any character and as many as you can, followed by another vowel. So it finds this E and it finds this U, okay? And it replaces this whole pattern, E through U, with a dash, okay? And then it finds this I, okay? And then it says find another vowel and it finds this O. And it matches everything there and it replaces with another dash, okay? And so it puts 2 dashes there in a row. And that's what threw me off because my brain only saw one of the dashes and it replaced all of this, okay? And then all of this, the O through the U and Fox jumps, it gets replaced and all of that. Okay. Anyway, this is regular expressions. I think it's so great. I didn't put it on your homework. I'm not putting it on a test, so I don't know how much you guys are going to study this. But you can do really great and powerful stuff with it. I was hemming and hawing whether I should take it out of the homework, but shortened summer, I'll take it out of the homework. So anyway, we'll end here. We'll see you guys on Thursday. Good luck as you study for the midterm, and we'll see you then.